everyone, and I'm very excited to present this trial session or demo session on CCNP Security. So let's get started without wasting any time. So before we jump into the core part of today's session, I just want to have a quick round of introduction about myself. So I think it's a basic human behavior where the audience would obviously like to know about the trainer himself or herself, right? So here I am talking about myself. So who am I? I'm a technologist. I am passionate about technology. That's my bread and butter. It's been like 15 years, I think over 15 years, that when I started my college, I have fallen in love with technology, and I'm really passionate about it. And the trait of passion is not just limited to technology, but I am passionate about a lot of other things as well that I do from the bottom of my heart. And of course, all these things are bounded by or binded by the strong ethics that I have. The value, the ethics, the honesty, the curiosity, the drive that I have, I think that helps me to be a better trainer, that helps me to impart biased-less training to everybody whenever I am there as a trainer, right? So, yeah, talking a little more about myself. In terms of my education, I am a bachelor's of technology, as you can see over here. Um, I'm still pursuing my MBA, in fact, from one of the IIMs that we have in India, and so I've completed 1 year in with my MBA, and hopefully the second year turns out to be good as well. And of course, like every one of you, I am a family man, and there is no denying that we all love our families, and for us, family safety and family's love is first. So I'm not different from you guys in this case as well. Uh, Talking about another passion of my life. So, if any one of you ever ask me that if I was not a technologist, what would I have been in my life? And I will be one of those guys who will raise up their hands and say, I would be a stock market investor or a broker or maybe a trader, right? I love stock markets because they provide thrill, the adventure that I want to have in my life. I can't always go to the mountains and hills and have that thrill and adventure with the help of different activities. But yeah, I mean, this is not the same as what we do with the mountains. But yeah, when stock markets go up and down, yeah, the thrill and the adventure that it gives me, I really like it. All right. Um, but yeah, coming on to the core part of my uh, experience. So I have over 12 years of network and security experience, and it was way back. I think I'll tell you a story about myself. So when I was in college doing my BTech, the focus was entirely towards software engineering. I hardly remember anyone in my section, in my class, in my batch was ever interested in networking, let alone security. I don't remember. So when I passed my BTech, I think 12, 13 years ago, I already had three offer letters in my hand, one from Accenture, other one from HCL, and the third one from Wipro. Trust me, my college training and placement cell were not happy because once you have an offer letter, you're not supposed to cut short other people's chances by appearing in further interviews. But somehow I was able to do it, and I had three offer letters. And all of these offers that I had from these companies, they were like all inclined towards software engineering jobs, which I was not interested into. So, under a lot of pressure, despite under a lot of pressure from my parents, from my peers, from my friends, I decided that I will not pursue the software engineering line. I'll go ahead and pursue a track towards networking and ultimately security. Right. So I started my career with McAfee. With my own hard work, I landed up with McAfee. I started climbing up the stairs. I got myself into Edison. I worked with Cisco. I have also worked with Zscaler, which is a exciting cloud security company. I have worked with endpoint security as well when it comes to Sophos. So I started working with Cyberhome, and Sophos acquired Cyberhome. And so I have also worked with perimeter security, firewalls, IPS devices, even the endpoint security. So I think that's all about me. So what we will do is we will go to the next slide and talk about what the subject is in hand today. So we are going to talk about CCNP security because that's what we are here for. So yeah, so what is CCNP security? Just another Cisco certification? Yeah, kind of true. It's just another Cisco certifications. We have got many of them that we will look at, right? What it will help you in becoming? It will help you in becoming a Cisco security ninja. Yes, you can show off your skills after learning different concepts like VPN, different kinds of VPNs, Flex VPN, Get VPN, IPSec VPN, SSL VPN, right? We are going to look into these concepts, and trust me, once you swim with me, deep dive into the ocean of these technologies and concepts, you will really love to show them off to your friends and to your peers, right? But there's a catch over here. What I am going to train you is not just CCNP security, right? I mean, I know you all want to be CCNP security. You want to pass the exams. Yes, we will completely focus on that, on the syllabus, on the exam pattern and the outline. But if you are somebody who is already into security line, if you are somebody who just want to come back to the basics, brush up your network security basics, you all are welcome. The course is for everyone. Trust me, the course is for everyone. And I can't put more emphasis that this will be a fruitful journey for everyone, right? And one of the basics requirement that I always has is in my training sessions is ask questions. Please do ask questions. Be brave. Don't hesitate. No question is stupid. Let me first of all declare or claim it in front of everybody. No question is ever a stupid question. You can always go ahead, raise up your hand, interrupt me in an ongoing session and ask your questions. I would love to answer your questions, right? So this is CCNP security, but it's not just CCNP security. It's a step ahead of CCNP security. The course is for everyone, right? Okay, so moving on to the next part. So now we know we are going to talk about CCNP security, but we should know why we have to do this. What will be the process and what are the outcomes we are looking at, right? So, I mean, in our life, whenever we take a step or we do something, we always do it because there is a purpose behind it. There's a reason behind it. If we are studying, then there's a reason behind it, right? How we are studying, there's always a set process of how to study, right? And what will be the outcomes, what I would get by studying, right? So I can explain another example. Let's take an example of say car. Yeah, you want to drive a car, right? So purpose is that you want to learn a car, right? So that you can commute yourself. You don't have to go for Olas and Ubers of the world so that you can drive it yourself. So that is the purpose for you to learn the car. Process is how will you learn it, right? You can join a driving school. You can ask your family member. You can ask one of your friends to help you out with the driving. Fair enough. What will be the outcome? Outcome will be that you will be a driver. You can drive a car and you can commute on your own, right? So similarly, the purpose of this course is to make sure that you guys have highest and the deepest understanding of security concepts, their implementation, and the troubleshooting part. So during the course, we will focus on this ocean. As I said, technology is an ocean. You can jump into it, you can swim on the surface, or you can dive, right? You know, the divers, right? They really put those flaps on their feet, and they put their own diving clothes, and then they jump into the water. They go really deep down in the ocean, right? So we will do the same. We will jump into this ocean. We will have a deep understanding of security concepts, how they are implemented, and the troubleshooting issues that are related to them. Another purpose is I want to make sure that you are able to position yourself as a better technologist in the industry. That is my ultimate goal. That is my ultimate purpose to deliver this training to you, is to make sure that you, yes, you as a person become a better technologist, better security engineer in the industry, right? And so, how we are going to do is, my style of training is to make sure that there is an immersive pattern to the training. You immerse yourself. Not only you, I will immerse myself as well with you guys. We will jump into this ocean. We will go as deep as possible, learning concepts. We will have practicals. I'll bring up the firewalls and the routers. I will start them up with a click, and we'll do all the configuration, troubleshooting, and implementation and building of topologies. That's what we are going to do in as part of this training. And what will be the outcomes? Of course, we all want more salary, isn't it? Of course, we want career advancement. Yes, so you get this. You will get it once we are done with this entire training. So I hope you all are clear with the purpose, process, and outcomes. I will keep on elaborating during the course of the training over the next coming weeks, right? And yes, the ultimate outcome will be that of a prestigious badge that you will earn from Cisco, that is of Cisco Certified Network Professional in Security. This is, I mean, it should be an honor for everyone. People who really put an effort into learning technologies, uh, making sure that they have sleepless nights and they study hard. It's really an honor for them to have this patch, and I hope you all will go ahead and clear your exams with flying colors. Right, so having said that, I just want to quickly touch upon the big picture and where do we stand with respect to CCNP security in it. So let me grab my pen. So we have CCNA over here, right? So CCNA is just one exam that you can give, you can take, and if you pass it, you get your CCNA certification. And it is common for all the tracks that we have. You can see I've got the tracks over here: enterprise, security, service provider, collaboration, data center, DevNet, right? So we are here. This is what we are going to do, CCNP security. And you can clearly see CCNA is just one exam. Cisco Certified Specialist, if you just give one exam from these exams that I have over here, right? You get a Cisco Certified Specialist. It's again one exam, but the professional certification has two exams everywhere. You can see there is one mandatory exam that you have to pass, and then the second one is a concentration exam, concentrating or getting familiar with a single technology. We'll look into it in the next slide, that how the outline and the pattern looks like. Right. So talking about the outline and pattern of this CCNP exam, right? So as I said in my last slide, there's a core exam that you have to appear for. It is called Implementing and Operating Cisco Security Core Technologies version 1, and here is the exam code. I'm sorry. Now this is mandatory. You cannot run away from it. This exam has to be, you need to pass this exam, right? And then for the second exam, we have a choice out of all these six different kind of technologies. Either you can learn and give exam for Cisco Firepower, or Cisco Identity Services, or email and Cisco Email Security Appliance, Cisco Web Security Appliance, VPN, or you can talk about automating and programming Cisco security solutions, right? As part of this training, we will be covering the core part or the mandatory part. And for our choice exam, concentration exam, we will go with VPN over here. I know, you will have questions at why VPN, why not some any of the other exam. So let me go back uh, and take you to the slide where I introduce myself. And as you know, I have worked with different companies, and as part of these companies, I regularly interacted with the customers. I have worked with companies like Nestle, Department of Defense, US, right? Uh, Bentley Motors and GE and all these kinds of companies. Every time I was talking to these customers when I was working with corporates, I realized 99.99% of times they had VPNs. I'm not sure all the companies implement Cisco Firepower. I am not sure if all the companies are using Cisco's identity services. And I'm not even sure that all the companies in the world are using Cisco's email security or web security, right? But I can bet that if there is a company or a corporate house with 2 or more locations, they have a VPN, right? And that's my reason. Why should you learn VPN? It has got more opportunities to grow. You will have more opportunities to grow and find in your career. So hence, we will be going with, of course, the core exam and the one that I have highlighted here in yellow color, the secure VPN exam. Right. So having said that, we will move on to the next part. Yeah. So as part of the demo, what I have decided, I thought I will give you a brief sneak preview of VPNs. What is VPN? And then we will talk about IPSec VPNs and how to configure them and the nitty-gritty of different VPNs. So what exactly is VPN? So VPN stands for Virtual Private Network. And why do we need them? There are situations where we need to send data over a network. And it is simply a technique to add more security, right? I'll give you an example. So there are 2 kinds of VPNs: site-to-site VPNs, right? Site-to-site VPNs, and then we have remote access VPNs. Yeah, there are only 2 kinds of VPNs that exist. Now, technologies will be different. Like you can have IPsec VPNs, you can have DM VPNs, Flex VPNs, SSL VPNs, but majorly they all fall into these 2 categories: site-to-site VPNs and remote access VPNs. Right. So moving ahead and talking more about VPNs. So what I will do is, now you can see a topology over here. I'll take an example of this topology to explain you a bit about VPNs, that why do we need VPNs. Now you can see I've got a network topology over here. I've got 2 locations. Let's say this is Mumbai and this is Delhi. And both these locations are connected to the internet. Of course, we have companies and they have, say, lease lines or broadband connections at their places, and they're connected to internet, right? So this company has one location in Mumbai and the other location is in Delhi. Now, inside these networks, we have network 1 over here and network 2 over here, right? And this is a local area network. The network over here is 10.10.0.0/24, and the network over here is 192.168.0.0/24. Now, these 2 are private networks, right? These 2 are private networks. And what we know from our already existing knowledge from CCNA, I assume that you have basic knowledge of networking, because then there's no point of going through CCNP Security. You must go through CCNA first, right? So if I want to make sure that PC1 talks to PC2, what do I have to do? Nothing. I can't do anything, because the moment I send traffic to say 0.2 over here, which belongs to a private network 192, my ISP over here will drop the connection. I cannot send any data from here to here. I cannot do that, right? So what's the solution? The solution is VPN. The network security engineer of this company will create a tunnel between these two routers over the internet so that PC1 can talk to PC2, right? And how will they do that? Let me grab an eraser and I will erase all and then I will start again, right? So now you understand, right? Now local area of network 1 and local area network 2, they cannot talk to each other, but we can make it happen with the help of tunnels or virtual private networks, right? And they are logical connections created over the internet. So what do we do? So to protect, so even if, so let's take an example. Even if I create a VPN from R1 to R2 or from Mumbai to Delhi, I need to make sure that when PC1 is communicating to PC2, the data is secure. No one is able to read the data or the packets. So to protect, we send the packets encrypted, right? We encrypt the packets. And in our further discussion during this session, we will configure both R1 and R2 routers to create a tunnel, to negotiate a tunnel between them. The negotiation that happens over here is known as SA, Security Association. They create a relationship, they negotiate a relationship, just as in different routing protocols, OSPF or EIGRP. The routers talk to each other and they negotiate and become friends, neighbors, right? Similarly, we will configure R1 and R2 in such a way that they are able to create a relationship known as security association among them. And we will be making sure that the data is encrypted so that no one on the internet is able to look into this tunnel or in this security association and is able to read the packets, right? So when we create a tunnel from one location to another, it's called site-to-site VPN. Why? Because we are connecting two sites to each other. We are connecting two sites to each other, right? So what is remote access VPN? Your question could be then, okay, site-to-site VPNs, what is remote access? Remote access is if the user in front of this PC1 tomorrow goes to his home, right? Here his home. He goes to his home and opens up a laptop, and now he wants to access PC3 or PC2 from his home. How will he do it? He will need something called remote access VPN. So it's kind of a software client, a little software that you can install on Windows machine, or you can install on Linux machine or MacBooks, and you can just fire it up and it will connect to, say, this router, right? It will his laptop, and this router will negotiate a tunnel. They will create a tunnel, and then the traffic will be encrypted, sent to the tunnel, sent to the router, and to the internal server or application that a user is trying to access, right? So I think this is the overview of VPNs. Now let's go ahead and see how we can do encryption. So as I said, if you remember from the last slide, I was talking about that you can create tunnels between two locations, right? Between two locations, and in that case it was R1 and R2, and both R1 and R2 can negotiate a security association and create a tunnel. But the problem is, if my internal PCs, in our example it was PC1 and PC2 from network 1 to network 2, if they communicate with each other, it has to be private as well. I don't want anybody on the internet looking into my tunnel and reading and able to read the data that is being transferred through the tunnel, right? So the advantage of VPN is they give me two things. What are those two things? Two important things: confidentiality and privacy. And how does it happen? It happens with the help of something we know as cryptography, right? So what is cryptography? So I'll give you an example. Um, in old times, in medieval times, when there was no electricity, there was no technology, and these kings and empires used to go at war, right? They do have had spies, right? Mm, collecting intelligence for them, right? So how they used to send information to each other? They used to send information in an encrypted way. For example, here's this man who wants to send, say, this data ABC to this man over here, right? So let's say person X and person Y, right? So X wants to send ABC to person Y, but he wants to make sure that nobody is able to read this message while it is in transit. So what he will do is he will scramble it, right? He will put, okay, star star hash, no, star hash, yeah, star star hash, something like that. And this person will know the key to decrypt it. Maybe the key is that A stands for star, B stands for, say, underscore, C stands for hash. Now that's the key. So now this guy will apply the key. Okay, star means A, underscore means B, hash means C, and he will decrypt the message, right? This is how the the cryptography worked in old times, but now since we have technology, things have really changed. So what has actually changed? Let's have a look. Let me clear the stuff over here. Right. So today, now I'll talk about two people. One of them is Alice, and the other one is Bob. Right. Now, Alice is over here, Bob is over here. Now, Alice is sending him a message saying, Bob, stop trying to make fetch happen, Alice. Now, she wants to make sure that no one is able to read uh, this text. So, what she will do, she'll take a public key over here and encrypt the message, and we will have a encrypted message, which is also known as ciphertext. And when this message will reach Bob, Bob will use its private key to decrypt it. I know, it's getting confusing. It's getting confusing. Now I'll clear it and I'll go back again so that you can understand with more clarity, right? There are two kinds of encryption methods, right? One is asymmetric encryption method. We call it asymmetric. Sorry, pardon my English writing. And the other method of encryption is known as symmetric encryption. Now, I'm not a mathematician. Pardon, I was never good in maths. I'm guilty, yes, I was never good in maths. But yeah, as far as I know, I will try my best to explain you, because this is not about technology. This is not about Cisco. This is about mathematics, right? So there are two kinds of encryption methodologies we have: asymmetric and symmetric. In asymmetric, there is a concept of private key and public key, right? So the concept is anything that you encrypt with public key, anything that you encrypt with public key can only be decrypted by the corresponding private key. I'm repeating again. Anything encrypted by public key can only be decrypted by its private key. This is how the mathematical algorithms of formulas has been designed. I'm repeating again. This can be a little overwhelming because I'm putting myself in your shoes, and I know when somebody taught me this thing 10, 12, 13 years ago, I was like, what? You encrypt something with public key, but you can't decrypt it again with the same key? I mean, at my home, I have a lock. I use the same key to lock it, and I use the same key to open the lock, right? There's no different key. No, this is what asymmetric is. If you encrypt something with public key, you can only decrypt it with the help of its private key. You cannot decrypt it again with its public key. No, that's not how mathematical formula is. Let's take an example. I have this data, ABC, right? I take a public key and encrypt it, and it gets encrypted. It becomes star star hash, right? It's encrypted. Nobody can read it. Now I want to decrypt it. I want to get the data back. I cannot use the same public key on it. No, that won't work. I will use the private key on it, and I will get the data back. I hope I'm clear. So this is exactly what is happening over here, right? Let me grab a pen of different color, right? So this is what is happening over here. Alice and Bob are communicating to each other. Now Alice is sending the message, Bob, stop trying to make fetch happen, and blah blah, and it doesn't matter what message it is. So what Alice does, Alice takes Bob's public key and encrypt it, right? We get a ciphertext, which means encrypted text, right? Nobody can read it. But now you cannot get the original method back by using the same key. You need a private key to get the original message back, to decrypt it, right? You encrypt with a different key and you decrypt with a different key. You cannot use public key again to decrypt it. It will not work. This is simply what is called asymmetric encryption. I hope you guys are with me, right? This is simply called asymmetric encryption, right? Right. So as I said, there are two encryption methods: asymmetric encryption and symmetric encryption. Now we know what is asymmetric, where we have public and private key. What is symmetric? Boom. In symmetric encryption algorithm, the key is same. There are no public and private keys. You use the same key. Keys are the same. You use the same key to encrypt the message to get the encrypted text, which is called ciphertext, and you use the same key to put it over here and decrypt it to get the original text back. This is called symmetric encryption, right? It's simple. I mean, I know asymmetric is a little overwhelming to learn that there's a public key and a private key, and you encrypt things with public key and you decrypt things with private key. But over here, it is easy, fairly easy, just like the lock at our home. We use the same key to lock our homes, and we use the same key to unlock our homes. So this is essentially what it is, right? So this is how we get confidentiality in our VPNs. We have these keys. The router 1 and router 2 will have their public keys, their shared keys, and they will be encrypting that traffic with the help of those keys and then decrypting the traffic on the other side, right? In our earlier example of topology in router 1 and router 2, right? So this is how we achieve confidentiality, right? But yeah, there's a second component over here called privacy. I know my data is encrypted, but do I really know it hasn't been manipulated or changed, right? Has it been changed? I don't know. I mean, how can we make sure? We can make it sure with the help of privacy. Privacy simply means hashing. So there are hashing methods like SHA or MD5. So what is hashing, right? So these are by the way, these are called integrity methods, right? So we are maintaining the integrity of the data. We are making sure that the data hasn't been manipulated. When R1 sends some data to R2, I have to make sure that there was no manipulation of the data. The data was not changed. Despite it being encrypted, I still want to make sure that the data was not changed by anyone. So what happens is, let's say I have a data packet with ABC in it. So ABC is the message in it. So what R1 will do, R1 will calculate a hash value. Hash value can be calculated with any of these two or three, whatever integrity methods we have. And it will attach a small header with, say, a code C. It will apply SHA or MD5 on the data to get a value called, let's say we already have C in the data, so let's say the hash value is D, right? Are you guys with me? Let me explain again. Let me repeat again. A router will take SHA or MD5 and apply it on the data to get a value we call hash value, and let's say it gets a hash value D. Now when this data will go to router 2 will take SHA and apply it on ABC to see what value he gets. If he gets the D, the same value, it means data was not manipulated when it was getting transferred. Data was not getting manipulated. But if in case R2 gets a different hash value, let's say E, that means the data was changed. Somebody did something wrong with the data, right? So what I'm trying to say is, VPNs give us the option of maintaining a confidentiality of our data, and also they make sure that our data remains private, right? So I hope you all understood what concepts I was talking about. So let's move on to the next part. Yeah, the next is IPSec VPNs, right? So as I said, we will, in this demo, we will talk about IPSec VPNs. What are IPSec VPNs and how do they work, right? And why do we need them? So IPSec stands for Internet Protocol Security, right? And mind you, it's kind of like a 30 it's like a 30-year old technology. Trust me, it's a 30-year technology and we are still using it. And you will wonder how we are able to use a 30-year old technology still in this modern world. Let me tell you why. We are able to use it because encryption methods, hashing methods have got better with the advanced computing technologies that we have. So I'll give you an example. We were talking about asymmetric encryption and symmetric encryption, right? So asymmetric encryption can be done with the help of something called Diffie-Hellman groups or Diffie-Hellman algorithms. So Diffie and Hellman were two mathematicians who developed Diffie-Hellman encryption algorithm, right? And then we have symmetric encryption, wherein there is only one key, and those methods are AES, right? Then we have DAS. So DAS was the oldest. It is one of the oldest encryption we had. Now we don't no more use it because it can, our modern day computers can break it. So we have now 3DAS, which is again not that secure. People have been able to break it. We don't use it. But AES is the modern encryption method, which is far better than DAS and 3DAS, right? So now you get the answer to the question why we are still able to use a 30-year-old technology. We are able to use the 30-year-old technology because our encryption algorithms, our hashing algorithms are getting stronger, and we are kind of going away or not using the old methods. We are kind of not using them, leaving them alone in the oblivion, right? Fine. So talking about IPsec VPN. So as I said, in IPsec VPN, we have a router, right? And router 2, router 1 and router 2. What they will do is they will create a logical tunnel. And to create a tunnel over the internet, we need to configure it. We need to tell them what encryption method they have to use. I mean, what asymmetric encryption method they have to use, what symmetric encryption method they have to use, what hash they have to use, or the integrity methods they have to use, what kind of authentication they have to use, right? We tell them in IPSec VPNs, and once we tell them, they can form a relationship which we call security association. Just like as I said in routing protocols like OSPF, EIGRP, the routers can create a neighbor relationship. They same here. I mean, not similar. I mean, I cannot say that, but just to give you an example, that they do create a security association. They negotiate security association among themselves, right? So let's look a little more into IPsec VPNs. What do I have for you? Right, here we go. We have got the faces. So IPsec VPN has two faces to it, phase 1 and phase 2. This is called ISACamp. It's a terminology. I mean, you can Google it and see what's the full form. I mean, it's a long full form of this phrase, ISACamp. And the second phase is itself is called IPsec, right? So what happens is, between two routers, R1 and R2, when they will start the negotiation to form a tunnel, they will form a phase 1 tunnel, right? And once the phase 1 tunnel is established, they will again form a phase 2 tunnel. So there will be a tunnel inside the tunnel. It's confusing, but we will look into it in more detail. I know it can be overwhelming sometimes, but that's how it is. So what will happen is, on router 1, we will open the command line, right? On Cisco routers, they work on command line. We will open the command line and we will configure phase 1, where we will tell what encryption algorithm you want to use. I will say, okay, Mr. Router 1, you will use AES as your encryption algorithm. Hashing algorithm SHA. Mr. Router 1, you will use authentication method as pre-shared key, right? And for asymmetric encryption, you will use DH group, right? So I will configure phase 1 and then I will go ahead and configure phase 2. Again, I will tell for phase 2 what encryption method has to be used and what hashing algorithm has to be used. Yeah, I have mentioned PFS over here. PFS stands for perfect forward secrecy, but it is mandatory. You do not have to configure it. But since it's a demo class, I'll skip it for the moment. But if you join my further course, we'll talk about PFS in detail. If you don't even bother about PFS, you don't kind of configure it, you can still make the IPsec work. It is not a mandatory component to configure. So as you can see, you can configure phase 1 and phase 2. And once you have done, what will happen? Let's look at how these phases are established, how router 1 and router 2 will establish them, right? There you go, right? So the router that will initiate the traffic, right? There will be a private network over here behind the initiator and the responder. In our example here, it was a 10 dot something network, and here it was 192 dot something network, right? So a computer over here will ping this computer over here in this network. Let's call it network 1 and let's call it network 2. So a computer in network 2 will initiate some sort of traffic, let's say a ping, to a computer in network 1. So that router will become an initiator, and if any computer from this network initiates a connection or any traffic towards network 2, then this router will become an initiator. So in our example, here is an initiator and here is a responder. Now these phases are also known as IKE phases. IKE stands for Internet Key Exchange, right? Internet Key Exchange is a protocol which defines how keys will be exchanged, right? So what will happen is, in phase 1, 1, 2, 3, 4, 5, and 6 messages are exchanged. So if I go back to my, if you remember from the previous slide, uh, in phase 1 we will tell what kind of encryption has to be used by the router, what kind of hashing has to be used, what will be the authentication method, right? What will be the Diffie-Hellman group that the router has to use for establishing a VPN, right? We will all tell this to router, to both the routers. And mind you, phase 1 and phase 2 should be same. The configuration, the components, you cannot say that Mr. Router 1 you have to use DES as encryption method, and Mr. Router 2 you will use AES. No, then negotiation will fail. They need to have the same encryption method, they need to have the same hashing method, they need to have the same pre-shared key, and they need to have the same Diffie-Hellman group configured. If you don't do that, the faces will not come up and tunnel negotiation will never happen, and there will be no security association, right? So let me erase the scribbles, and now I will explain you what happens in these phases. So as I said, you configure encryption, hashing, authentication, and Diffie-Hellman group. And once you initiate a traffic from here, what router 1 will do, or the initiator will do, it will take the policy and send it to the responder and tell to responder, hey Mr. Responder, I'm using AES, I'm using SHA, I'm using Diffie-Hellman group 2, and here is my pre-shared key. Responder will be like, okay, I have a same policy that matches the same policy, Mr. Initiator. I accept your policy. So in message 2, the policy will be accepted. Now in message 3, what will happen? Initiator will be, okay, thank you, Mr. Responder. Now we agree that we have the same policies. Now let me give you my public key. remember our asymmetric encryption, right? When I tell them to use a Diffie-Hellman key or Diffie-Hellman group, they will generate a public key and a private key. Similarly, the responder will also have a public key and a private key, right? Now in third message, let me grab a different color pen. In third message, initiator will send its public key to the responder. Now responder will have initiator's public key. He has its own public key, its own private key. Now it also has public key of the initiator. Now the responder will do the same. In the fourth message, responder will send its public key to the initiator. Now initiator has the public key from responder, right? Now we are completed with the 4 messages. Now these 4 messages are clear text, which means if somebody is on the internet and is kind of capturing these packets, he will be able to grab the public key. But the public key is of no use. And you don't know why? Because anything encrypted by public key can only be decrypted by the private key, and they do not exchange private keys. The private keys are supposed to be private and they remain private, right? So what will happen is, now they know the public key of each other. Now they will generate a session key, right? Which means symmetric encryption will come into the picture. As you know, we told both of them to use symmetric encryption as AES. So they will use AES to generate a session key, and both of them will generate the same session key. Now example, responder in generated a sessions key called ABC. Initiator will also generate the same key. Why? Because we have the same policies. Now you understand why do we need to have the same policies on both the sides? Because they will generate if there are no same policies, they will not be able to generate the same session key. So it is important for them to generate the same session key. uh, Let me remove this scribbles and have a clear page to write again. So as I was saying, this guy generated ABC as the session key, and the responder will also generate the same session key. Now they need to make sure that they have generated the same session key. They need to exchange their session keys, but they can't do it. Why? Because this is the same session key that will be used for the VPN to encrypt the traffic, right? So they cannot exchange it in clear text, because anyone on the internet, because these two routers are connected on the internet, anyone on the internet can read this key. So what they will do is, as you know, initiator has public key of the responder, and responder has public key of initiator. He will apply this public key and encrypt this. He will apply this and encrypt this. And now in the fifth message, initiator will send this key over to this side. And this guy, he will apply his private key and get the shared key over here. Similarly, this guy will do the same thing and he will get the shared key over here. That's it. The phase 1 has been negotiated and tunnel 1 is now up, right? Now the tunnel 1 is up. Now everything will be encrypted by these shared keys, and no one knows these shared keys, right? Because they were encrypted by the public keys, and if somebody had that public key, they cannot apply the same public key to decrypt the data, and private keys are always private. Now the tunnel negotiation will move to phase 2, wherein hash IPSec proposal will be negotiated, which means we need to tell this router that when somebody from source as 10 and destination as 192 is initiating a traffic, that has to be an IPSec traffic, right? So they will negotiate the IPSec proposal, right? So initiator will send a IPsec proposal, and then responder will send his proposal, hash will be exchanged, and phase 2 will be up. So this is how the IPsec tunnel will be started. Now in the next steps, what we will do is we will look at the uh, configuration that we have to do on both the sides, right? On router 2 and router 1, and we will see how the logs look like. How the logs look like when we initiate the tunnel, and we will see the policy configuration. We will look at the phase 1 configuration, we will look at the phase 2 configuration, and then we will start the uh, tunnel. We will capture the packets through Wireshark. We will go through the Wireshark where we will see the messages getting exchanged. As we know, the first 4 messages are clear text, so we will see them as clear text messages in the Wireshark, and then the messages will be encrypted. We won't be able to read them, right? So we'll verify everything. We'll see how packets are decrypted and how packets are encrypted. So let us move on to the next part, where we will talk about configuration.